Welcome back, Math 2. Today we're going to continue that discussion about the geometric mean. We're going to use it to find more pieces of the triangles without never mind. Anyway, okay, so there was the first corollary, which stated that the length of the altitude was the geometric mean of the two segments of the hypotenuse. There is also a second corollary that has to do with the legs of the triangle. And it states that each leg of the triangle is the geometric mean. I'm just going to call it the geo mean of the closest or adjacent segment and the whole length of the hypotenuse. Okay, so let's just kind of dive into doing some examples and maybe it'll make more sense. Okay, so first off, what is a leg? Okay, so a leg is any one of the three sides of the triangle. Okay, now our triangles all happen to be right triangles, which means that one of our legs is just always the hypotenuse, and that's this one here that I'm erasing right now. Okay, so what this is saying is that each of these legs, z and y, is equal to the geometric mean of the piece closest to it or adjacent to it and the entire length of the hypotenuse. So let's say I'm going to solve for z first. Okay, z is my geometric mean. So when I set up my proportion, z is going to go in there twice. And it's the geometric mean of the segment closest to it, which is 5, and the length of the whole hypotenuse. So if I combine 5 and 15, I get 20. So now I'm solving cross multiplication this way. So I end up with z squared equals 100. I'm going to square root both sides, and I get z equals 10. Okay. Now y is similar, except that what's going to change, we still need that whole length of the hypotenuse, and y is still the geometric mean. But instead of using 5, I'm going to use 15 because that is the piece closest to y. So it's going to be that y squared equals 15 times 20, which is 300. We'll square root both sides. And I get 17.3. Okay. Let's try it again with number 2. But you know what? Number 2, we will just solve for y. Okay. So again, that leg piece is the one that's going to be used twice, just like the altitude was used twice in our last notes. Okay. So y, I need the segment closest to it. So my two segments are 9 and 3, but the one closest to it or next to it is 3. And then I need the length of the whole hypotenuse. I don't want individual pieces, I want the whole thing. So 9 and 3, make 12. And I'm going to cross multiply. So I will get that y squared equals 3 times 12, which is 36. I'm going to square root both sides, and I get that y equals 6. Okay. Let's try another one where maybe we have numbers in for our leg. Okay. So remember, the leg is the piece that's the geometric mean. So it's the part that's going to get written twice. So in number 3 here, my leg is 15. That is going to get written twice. Remember, it's the geometric mean of the piece closest to it, that x, and the length of the whole thing, 25. Okay. So I'm going to cross multiply this. 15 times 15, I believe, is 225, but we'll just double check. Yep, 225. And then that'll be equal to 25x. And if I divide by 25, I get 9. So that little segment there is 9. I'm going to do the same thing with number 4. 6 is my leg. That part's going to get written twice. That is the piece that's the geometric mean, so it gets written twice. The segment closest to it is 4, and the whole length of the whole hypotenuse, which we don't know, is going to be our x. And cross multiply. So 6 times 6 makes, let me give myself some room here, makes 36, equal to 4 times x. I'm going to divide by 4, and I also get that x equals 9 this time as well.